Welcome back, team. Let's start. Let's not wait. Thank you everyone for making your time and giving time for this webinar on Streamline Performance Analyzer. Not pretty sure if the team is aware of this Streamline Performance Analyzer. If the team has, if anyone from this attendees have worked on Kyle MDK, then you can correlate this with the Performance Analyzer feature of Kyle. Basically, Streamline Analyzer is the feature of ARM Development Studio or ARM Development Studio 5. Earlier it was RVDS. I'm not sure it was that time it was there. So you can correlate that with the Performance Analyzer of Kyle. Let me share this. So only the name goes as ARM Streamline Performance Analyzer. So before that, a quick introduction. I know many of you are the attendees who regularly join my webinar, which we conduct technical webinars, which we conduct monthly. For the benefit of the new audience, if at all any has joined, I'm Geeta. I work as Director ARM Tools at Jesus Microsystems Private Limited. We are the only authorized and prime distributors of ARM software solutions in India. So we take care of pre-sales and post-sales support. And the webinars which I conduct will be purely technical to show the features of the ARM software, features which are included as part of MDK or DS or related to any ARM technology. There will be no commercial talk in this at all. So as the name suggests, Streamline Performance Analyzers. As I told, we can correlate this with the Performance Analyzer, a feature of Kyle MDK. So before jumping in the Performance Analyzer, I would like to touch up just 2 slides I've included about ARM Development Studio. For those who are new to this ARM Development Studio, ARM has given 2 types of software solutions based on the processor customer is planning to use or user is planning to develop the product on. If it is ARM processor based microcontrollers like ARM7, ARM9 and Cortex-M based MCUs, then ARM suggests us to go with the MDK, Microcontroller Development Kit. That's a different MDK license which we give from ARM. Another is if customer is working on higher end Cortex-A, 32-bit, 64-bit processor for real-time applications for ASIC, SoC related stuff, or big little combination. I'll talk about big little because in this slides there are many slides where big little word is used. So in such combinations, we for heterogeneous processor systems, multi-core systems, ARM suggests Development Studio. So it's specifically for Cortex R and A. That doesn't mean that ARM DS cannot be used for Cortex. It can be used. This is a single universal toolsuit which supports all ARM processors, Cortex-A, Cortex-R, and M. But for M, MDK is most suitable and apt software because it has taken it shows all the advantages of the Cortex-M processor features or RAM processor features, which is being hindered or not included in DS. Okay, so DS stands for Development Studio. If anyone is new to this, if at all, if anyone has worked on DS5 Development Studio 5 or ELV Developer Suite, you can correlate this. RVDS was replaced with DS5 Development Studio 5, and then Development Studio 5 was stopped from September 2019 onwards, and from there, Development Studio came into existence. But all the 3 IDs from RVDS to DS5, DS5 to DS, all are Eclipse-based and all request Java Virtual Machine to be running on the system for this Eclipse to run. As everyone knows, Eclipse is open source IDE to which the CDT plugin ARM compiler has been plugged, and all the features, optimizations, everything has been done by ARM. So ARM Development Studio will help you to create and build the code. I mean, because it's an IDE, integrated development environment, we call it as. where all the tools like compiler, assembler, linker, debugger, everything is linked in, everything is integrated in the IDE. So DS will always be the first software to support all latest ARM processor support. So whatever the latest ARM processor cores ARM releases to the market, even before silicon vendor, when the semiconductor vendor comes with a microcontroller or a processor based on it, the device, the processor support will be included in the DS. So even before the processor is released to market, or even before the processor becomes popular, you can use that for your even POC concept or any for development purpose. ARM, as hope the team knows, ARM strategies, they never manufacture silicon of its own. The semiconductor vendors licenses their IP cores. It can be Cortex M series, Cortex E, 64-bit, 32-bit, Cortex R. I'm just telling you the device variants, but in that various configurations of Cortex R, Cortex A, Cortex M. Like for example, if I go for M, I have M0, M plus, M3, M4, M7, M23, M33, M35P, M85, M55, like that. Like that, in also in Cortex A also we have various processor series, various 64-bit and 32-bit and everything. But ARM, though they doesn't manufacture silicon of its own, they have developed this ARM compiler which goes as part of microcontroller development, which is Kyle as well as DS. The same ARM compiler is used in both the software. So ARM has invested a lot of time and resource. They have spent a cost also on developing this compiler, and because they have developed this IP cores, so they'll be having a good hold on what is the maximum optimization or best optimization on how to get the best optimized code from that specific processor. For that compiler, what specific optimizations, options, everything has to be included. So this everything is taken care by the so it will help you in generation of optimized code generation. Next, debug the code. You can also visualize the code. I'll come to debug the code. As the name suggests, debug, everyone know what is debugging. I need not explain. So you can inspect the CPU state execution. You can set the breakpoints, debug the exceptions, interrupts. If you want to view cache, MPU, MMU, this is all part of Cortex A. We don't have cache, MMU, and all in Cortex M. We have, and we can also see or debug the multiprocessor system, like it can be asymmetrical multiprocessing, symmetrical multiprocessing, big little, dynamic. So since this big little has come, let me give you the example. If anyone knows, it will be a repetition for you. As a name suggests, big little means this particular technology was implemented by ARM, where the system had multiple processor cores, where it had a combination of lower end processor core and the higher end processor core. So lower end processor core was called little and higher end processor core was called big. So if I take an example of a hybrid processor cores from NXP, early it was Freescale. That's a combination of Cortex M4 and Cortex A. So in this case, Cortex M4 will be little and Cortex A5 will be big. So in such big little combination, they can try to optimize the system, where at power on reset, the small, like in example, Cortex M4 starts executing, till then Cortex A5 will be in standby. So A5 will do all the system initializations which is required, and then it will release the Cortex A5. Then Cortex A5 will take care of all higher end processing. So lower end processing will be still done by the Cortex M4. Thereby the CPU is utilized to its maximum extent based on the application requirement. This technology was brought by ARM very long back. DynamIQ is actually it's called dynamic IP clusters. So the system, if you take a heterogeneous or a more complex system, it can have multiple CPU cores, and each cluster can have multiple cores. So DynamIQ till now, before DynamIQ technology was brought by ARM, it was only the clusters can have either 2 core or 4 core or 8 core or 16 core. With the DynamIQ, we can have even 13 cores also. So like that, there are some features which was implemented in ARM. I'll just give an overview. If anyone is interested, if you go to arm.com and look for DynamIQ, you'll get all the information. Visualize the code. So we can view the code history up to a breakpoint. We can set a breakpoint here in real time. We can do the OS level debugging. And we can also, with the help of this Streamline Analyzer, you can also optimize your code, which we'll be talking about in these coming slides. So tool designed, this is for the entire product life cycles, means even before your hardware is ready, for every stage of the software, that is SDLC, every stage of SDLC software development lifecycle, ARMTS can be more useful for the user. So even before the hardware is ready, you can use the simulation models offered by ARM, where we can develop your code and test the code on the simulation model. Then once your hardware is ready, once your hardware code is ready, you can use the JTAG DStreamST debugger, load the code to the board, and do the real-time debugging. If it is higher end, if it is lower end, you can use the Fueling Pro debugger like that. So what is included in ARM Development Studio? You have IDE, which is Eclipse IDE. We have ARM debugger, Streamline Performance Analyzer, Mali Graphics debugger, because ARM also has Mali Graphics. There's a graphics GPU, graphic processing unit. The C or C++ compiler, we have ARM compiler for embedded FUSA and safety certified library means. Some versions of ARM compiler are safety CUV SUD certified, safety certified for developing the code for safety critical applications like railways, medical, automotive, industrial. Then you have simulation model. Then you have fixed virtual platforms. These both are simulation models. Okay. These two slides is to just give you the quick touch up on the DS, because this Streamline Performance Analyzer, what we are talking about today, is part of ARM DS license. Okay, you cannot, though it can be run as a standalone without running ARM DS IDE, but to run the ARM Streamline Analyzer, you need to have the ARM Development Studio license. So that was the reason I included it 2 slides of ARM Development Studio. Okay, now coming to the actual topic. So as the name suggests, Streamline Performance Analyzer. So basically to enhance the performance of the system, to optimize the performance of the system. So how you can do it? By finding out the bottleneck in the system, where where we are losing the performance of the system. So with the Streamline Analyzer, you can find out where is the actual bottleneck. It can be in terms of CPU or other pieces of IP, whatever is the FPGA or SoC or ASIC. And next thing is, it will tell you the hotspots in your application. Hotspots in the sense where the CPU is spending maximum time, which part of the code, which part of the function, which part of the thread or whatever. So with this, you can have a level granularity of your CPU usage at the process level, thread level, function level, and code level. So if you come to process on that, if you show this particular process, in that if you want to find out which thread, you can find out in that thread which function, and from that function, not entire function, maybe processor may spending in that only few C statements of that particular function, or some part of the function body is where processor is spending time. So all those it will be able to show you that hotspots on these levels. So this is your ARM Streamline view, how you get it. So here you can, as just now I told you the previous slide, you can speed up your code in the sense you can find out where the CPU is spending maximum time, and thereby you can try to optimize that part of the code so that your system performance increases. And here, as it shows like a graphical view or a pictorial view, from this we can drill down to specific function, and from that function specific source code as well. Along that, we can also view the disassembly view as well. We can also include or add energy probe of ARM to calculate or to find the power consumption in your application. So thereby you can also correlate the software execution to the actual power consumption. And here the Streamline is very flexible. I'll tell you how Streamline works. We can add new counters. And what are those counters? I'll tell you. So basically how the Streamline works, I'm explaining the example of Linux system where Linux is already ported, a hardware board or an SoC where Linux is already ported. So how it works is Streamline is an agent-based architecture. Means once you run the Streamline on the hardware, it doesn't mean that it will start showing you all the details. No, there should be some agent, some part of the code running on your hardware, which will capture the relevant information from your target board. So that agent is called as Streamline agent, and in case of Linux, it's a getter daemon. Okay, getter daemon. This we include as a Linux kernel object. We link with the Linux kernel as a kernel object file, and when we port the Linux onto the board, we also port along with this getter daemon. And this is the agent which will collect all the related information. How it collects? Through the counters. Higher end processors like Cortex-A, Cortex-R and all, they have CPU counters. Suppose, as I was telling, with the help of DS, you can have a visibility of cache, MMU, MPU. So in the cache, you have the option of cache fill, cache miss, cache hit. Suppose if you want to find out, suppose to know how many cache hits happen. So that's a positive thing, right? So processor every time it requests for a data, the data is available on the cache. So that's a cache hit. Suppose if the cache miss happens. So cache miss means it's like degrading the performance, means a processor is not able to get that particular information from the cache. Cache refill, how many times cache refill happens or pipeline refills happen? Because when pipeline refill happen, when there is a branch, when there is a branch, it can be interrupt execution or function execution or exception execution. So ARM believes every time this pipeline is flushed and it is filled with a new address, that number of amount of CPU cycles are wasted. So they treat as that is a called of degradation of CPU performance. Okay. So how they do it? It is through these counters. So to find out how many cache hits happen, there is a counter associated in the CPU. And with that CPU counter, we can find out how many cache hits happened, miss happened, refill happened, everything. So this Streamline agent, getter daemon, will collect the information about these counters. How it collects? It samples these counters at a time, at a regular time. You may be telling, Madam, Cortex-A might have so many counters, probably 10 to 20. So Streamline will still sample all these counters? No. When you are initializing the Streamline Analyzer, we have to specify which specific counter you want to see the performance. Like I want to see only cache hit and suppose cache refill. I don't want to see cache miss. Then whatever counter I added, only those counters will be sampled and it will give you the information. So that is how getter daemon works. So Streamline given by ARM is a agent-based architecture. So this getter daemon concept works only for OS, Linux, Android, or Mantizen. I'll come to that. Okay, so now you saw in the previous slide how the Streamline shows. This is the timeline view. It shows the entire system performance metrics, okay, against the time. So if it's a Linux, it will also show the application running in user space or system space, all this information. Instruction level, cache level, branch, as I told, branch prediction, branch mishap, and everything. Because as I told, branching is treated as a degradation of CPU performance. So all higher end processors, including Cortex-M, has branch predictor units. So these branch predictor units will predict whether the branch will happen or not. Okay. So So after this, you have call paths. So call paths is here, if it is in nested functions, you can see which function has called which function like that. And you can also see it shows you in this color codes. So color code means dark red indicates it's this particular function where the processor is spending its entire amount of time. And as the color fades, you can see that those are the functions where processor is spending less amount of time. So basically the hotspots in your application, it shows the call paths along with this information. So from this, we can come to the function, and here, this is a function view, which will tell you again based on the hotspot. And when I click on that particular function, it will also tell you these red colors. So you can also drill down to the code level. Because as I said, that entire function may not be where processor is spending time. Only few C statements or such only particular part of the function only. So that also you can see that in the code level. Okay. So this I've already told. Streamline is basically to identify the hotspots and system bottlenecks in your system. So here it shows the graphical view. First, which particular suppose user or system, like in green color, where it is spending maximum time or hotspot. And from there, you can drill down to the particular function or in that function with specific code, like here. So it will also accumulate the counter related information based on the whatever the settings you do in the Streamline Analyzer. So it's the same thing which I explained. So call path, from there it goes to function, and from the function level, if you click, suppose if I click calculate function, it should show me. It will show me like this. In that particular C function, what are all the C statements where processor is spending time, and it will also tell the percentage of the CPU time spent. So you can see here this is 74.14%. So accumulate this particular C statement is where processor is spending 74% of its CPU time. So thereby you can try to optimize this particular C statement and try to write it as simple as possible so that processor just takes few whatever percentage and quickly executes and comes out. So this you can actually optimize your code. Okay. So you can also do the optimizing on core and cluster. As I told about multi-core and clusters having multiple cores. So you can see it on the multiple core level as well as on the cluster levels. So CPU activity, if it is multiple cores, you can see based on the colors, 1, 2, 3, 4, 5, here it is shown probably 6. So you can see which particular core where the code has been executing more by which specific core, how much percentage of the code or how much percentage of the CPU time or core time is used for the execution. All those information we can find out. So this is also helpful in big little systems, which I explained. So same thing, top-down for software profiling. So top-down software profiling is first we will from the graphical view, we will come to the function view, and from the function view, we will come to the code view. And here also, if you want to only profile some specific part of your code, only you can also do that. Filter the timeline to generate only the specific software profile reports as well. Suppose this particular function, if I see, you can see here kind of turmeric yellow and red color, not that dark red. So like that, based on the color coding, you can understand where the CPU is spending time. And disassembly view also you can see the codes which are executed, it shows in the light green. So thereby you can also make out, because every is Every C statement has a set of assembly instructions associated with it. So it shows what are all the assembly instructions executed from the disassemblies. This is bottom-up shared library profiling. Means if at all your application is calling a specific library um, from your code, so that also you can find out. Like you can select here from the functions window. We can go for select a processor or threading timeline so that it shows in this timeline. And then we can select which specific library function you want to view, and then we can navigate based on where that function was called, how many times it was called, all those information. So that was command, that was GUI interface. If you want to make this streamline, you want to do the performance analysis in an automated way, there is also through command line interface you can do with the help of scripts. Okay, so with the help of scripts, you can do either manual or capture the data on specific time through the scripts. You can specify all this. Then we can filter the information based on start or stop bookmarks. Then it generates this text-based information like function call, path, stack, and all. Then we can parse and compare that report for benchmarking. So automatic streamline performance analyzer can be configured through GUI. You can also, to make it in an automated way, you can also control or write a script file and run it through command line. Annotations. So what are these annotations? Suppose these information to run this streamline analyzer, you don't require any debugger nor a trace. Okay, it's just you need to connect your hardware to the streamline analyzer through USB or Ethernet on your board, and you need to have a DS license. So what is this annotation? So annotation. Suppose in your program you've written some 10,000 lines of code. So I'm more particular or curious to know about some specific part of code only. Instead of streamline, in checking the performance for entire system, entire code, using annotations, I can tell to the streamline that only some specific points of your code only I'm interested to profile. Or you want to know the dependencies of specific code or different parts of your code, or you want to find the execution time of some specific or various different pieces of code. So using annotations, you can do all those. So the streamline can collect those information and share it with you. Okay, so whatever I explained in these slides, previous slides, was all, as I told, getter daemon is the concept which worked for Linux. Basically, for the kernel-related application, it can be Linux, Android, Prism. But does that mean that Streamline cannot be used for bare metal? So what is bare metal? Hope the team knows bare metal is the application where there is no OS involved, no RTOS involved, not operating system, not real-time operating system. So what will be such code? It can be a startup code because ARM processor is a complicated processor, and resets, whenever you give the power on reset to the processor, reset itself is the highest priority exception. So that has to be first serviced even before processor hits your CMain function. So this exception, this reset exception handler is defined in your startup code. I'm just giving an example. If it is a higher end Cortex A or a Cortex R, you may have to invalidate the cache, invalidate the TLBs, MMU initialization, TLB initialization, cache initialization, everything is done in your startup code. So even before the processor executes, and then it loads the Linux on the board or whatever, you unzip and load the Linux. I'm not a Linux expert. So bare metal can be anything. Doesn't mean that for Cortex and Cortex R, because it's higher end application, you have to develop the code based on OS. No, it's not mandatory. It's up to the application requirement, whether you want OS or RTOS, or you want to develop only bare metal application. So with the help of Streamline Analyzer, we can also analyze the bare metal application. So how it is done? In these 4 steps: generate, instrument, run, import. Streamline bare metal I had covered once, probably last year webinar I did that I also demonstrated how this bare metal streamline bare metal applications can be captured. So what is generate? Because in C, Linux and all is just including the getter daemon as a kernel object model and linking with the Linux kernel. But for bare metal, it's a different thing. So we have to include agent as part of our C source code, correct? Because there is no OS there. So agent has to be part of your C source code. So first we will generate, instrument, run and import. So what is generate? First we will generate the agent. Barman we call it as, this is an agent for bare metal application. So generate will specify how many number of cores you want to profile that information. And from the streamline option of this streamline analyzer, we have the option select generate sources. So that will generate the Barman sources. So here we'll specify what all cores it has. If it is multiple cores, select all those checkboxes, and for all those, it will generate the agent, Barman agent. So thereafter you click that, then you can specify what are all the counters. These are the counters. You can see here cache data. In the cache data, TLB refill, data refill, cache line fill, branch miss predicted. Some of the counters you can see here. So in my bare metal application, which specific counter I am interested to see. So some example here, some selected, this is all PMU counters, we call it as performance monitoring unit. PMU, every processor, if I take Cortex M may not be, but Cortex A&R has PMU unit, which has a lot of counters, which captures the information about the processor performance, which these agents will sample and collect the information and show to us in the Streamline Analyzer. This is one of the best and unique feature performance analyzer which ARM has given in DS. Then you have to select the which particular counter, okay, and then you have to give the location means the folder or the location in a system where this Barman agent will be generated. That is bare metal Streamline agent is generated. It generates two files, barman.c and barman.h. So these C files, C file and header file, you have to add it in your project. So that's part of generate we have done. Now we have generated the agent for our code, and because this agent has to be compiled with our code, so that only then only it will capture the information about our performance related application, performance related to our code. So that you have to include in your C file, and then instrument. So instrument is whichever part of the code you want to capture the performance of the your code, specific function, specific C lines, or whatever it is, some critical part of the code, or whatever that you can instrument it by calling this, initializing this Barman library. All the counter related information will be stored in a memory, RAM memory, which we can enable the sampling of that, which Streamline will sample it, and processor will sample it and store it in their CPU counters, and Streamline will agent will collect those information and show it to you. This is first initializing the Barman agent, then instrument it, enabling the sampling, and whatever the information of the counters is there, it is stored in this buffer, whatever you initialize the buffer at the time of initializing of this Barman library. After that, we will run this code. We will build the code along with the Barman agent and download onto the board, run it. And after that, you import that data. Once you run it, it will generate some data. That data information you have to import it in Streamline Analyzer to see the performance of your code. This is how Streamline works for bare metal. So anyone wants more information on Streamline, you can go to developeram.com and We'll find the details. Just a second. I can show that for you. Anyone having a question, please put it on the chat window. I'll keep 5 to 10 minutes for answering that question. So Sarbajit, please put it on chat window. I'll just show you that. Go to components. You can see Streamline Performance Analyzer. Okay. So here you can see profiling your Android application, profiling your bare metal application, profiling your Linux application. So you'll get all the information here. Streamline Users Guide, everything. So this is available on developerarm.com. So any features offered as part of ARM software solutions, you'll get all the information on developerarm.com. And anything on processor related architecture, user manual, technology, you can go to arm.com. So both are maintained by ARM. Okay. So that's the end of this slide. Thank you. Let me come to questions, if any. One by one. Ramkrishna Ji, please put it in chat window. I'll answer. Can we profile NPU using Streamline? Can you get a demo about how to profile Android services using Streamline? Just now I showed on the developerarm.com, they have also given an example on how to profile the Android application. Okay. Demo I have to probably arrange from ARM because I'm not well versed with Android. Linux to some extent I know, but Android I'm not sure. So Arbachit, where are you from? Yes. So can you profile NPU? NPU is what is NPU? Put some processor unit, numeric process unit, or neon, not neon. What does NPU stands for, Sarpach? If your code includes any of the features of the processor, then it can be streamlined. We have Ambassador, can we get this or do we need to? Yeah, Krishnaji. You already have DS Platinum license, and I believe you have DS5 license also. Both comes with this the Streamline Analyzer. And as I highlighted, to run the Streamline Analyzer, you don't require any debugger. You have to just connect a USB or Ethernet cable to the board, and you have to configure that in the Streamline Analyzer how the data has to be captured from the board, and it will show it. You don't require any additional license. It comes as part of DS license, DS5 license. It can be gold or a platinum. Neural processing unit. Okay. Welcome. Neural processing unit, if I think you're talking about for machine learning, right? Right. See, if at all you're using machine learning, actually, there is CMSIS NN, Cortex Microcontroller Software Interface Standard, which was also extended to Cortex A. If you're using that, they have set out some APIs for neural processing unit, for neural networking only, specifically for ML and AI application. If at all you're using that in your code, because it's a set of APIs, and if you're using those in your code, you can certainly generate the performance of that through Streamline Analyzer. Yes, ARM has 8055 MPU. So Streamline can tap that as well. Yes, of course. Because this is NPU given by ARM, so certainly there will be counters in that as well. You read the data sheet of it, so there will be some counters part of PMU, which the Streamline agent will capture and show it to you. Probably this ethos is for M55, if I'm not wrong. Ethos U55 and Cortex M55 goes hand in hand. I'm sure. Okay. Any other questions? Okay, no questions. Demo on Streamline usage for performance will be helpful. Demo on Streamline usage for performance analysis and that will be helpful. I'll see if Palm has uploaded any video on YouTube to show this performance analysis on Android. I'll find out. I'll find out on YouTube if I'm sure Ram would have put some YouTube video for profiling on Android application using Streamline Analyzer. Otherwise, it is more otherwise it is more specific to the customer. So customer uses Streamline Analyzer for their application, and usually they keep it confidential. So we will not be having information for which specific use or feature Ram has bought the license. Some customers do tell that they have bought this for so and so feature of the DS. Then we can still find out. But I'll see if Arm has given some YouTube, or I'll check with Arm if they have any training video, something where I've shown profiling of Android, performance of Android application using Streamline Analyzer. Okay. Yeah. Any other questions? So I believe they've written Bangalore. Which company are you working for? Samsung. Great. You can send mail to Geeta Temple India. I'll put it on chat. Everybody can please send me the email. I'll certainly check it out. If it's Samsung, certainly I will respond. Okay. I'll check out because Samsung is they're one of the potential IP core licensor. So there are a lot of processors, MCUs, processors based on that. Okay, sir. Any other questions the team has? Right. So no questions. So thank you, team. Thanks for your time for this webinar. So next month I'll again come up with some technical webinar on some other feature of our software tools. We will send you the email. It will be sent from a marketing team. So if it interests you, then please join. Thank you. Thanks, Ramkrishna. Thank you, Sarvaji. Thank you, Rajan. Okay, see you. Have a nice evening. Bye bye. Take care.